So we've explored enumerate a little bit, but let's apply it to a specific problem where we are making a general form for a polynomial. So let's kind of disambiguate this mathematical formulation really quick. C here is a coefficient, and x is our variable, and then n is the degree of the polynomial. So what this might look like is something like, we could say 4x to the third plus 2x squared plus, let's say, just 3x plus 9. So 4x cubed plus 2x squared plus 3x plus 9. In this case, our coefficient list, c sub 0 is going to be 4, c sub 1 is going to be 2, c sub 2 is going to be 3, and c sub 4 is going to be 9. And notice that we've got length 4 here, right? We've got 1, 2, 3, 4 items, and we're going to expect to put these into a list. And our corresponding exponentiation of x is going to be the length of that list minus 1, minus the index, right? Minus 1. So we're going to start at length 4 minus 1. That's going to give us 4x cubed. All right. So let's kind of recreate this code that's over here, and I'll walk us through it as I type it out. So polynomial, we're going to take in a list of coefficients. So I'm just going to call this coefficient list, and I'll make it the same thing we just did. So this is 4, 2, 3, and 9. And we'll just use this exactly as it is. Our variable x, right, this is going to vary. And we can we can follow a simple accumulator pattern here where we have some results of 0. Our n is going to be the length of the coefficients minus 1, right? That's where we originally get our n. And then simply we can say for the index and the value in the enumeration of the coefficients, we can take that result and increment it by the value, right? The value is each item in this coefficients list. We can take the value, multiply it by our variable x, and we can raise that to the n minus the index, right? So initially, this is going to be it's going to be the length, right? Which in this case is 4 minus 1. So n is going to be 3 originally. So 3 minus 0 is going to be give us that 4x cubed, right? So that is where that's coming from. And we can just return this whole thing. So we return res. I'll go ahead and call it. So print, I'll do polynomial of the coefficient list. And let's do 2. So it's going to be 4 times 2 cubed plus 2 times 2 squared, and so on. So if I run this, name poly, okay, little error right there, just fix that. So 55, we get 55 out of that. Now if we wanted to take this a step further, we could analyze it through dictionary and give it a, feed it a range of values. There's all kinds of other things we could do with this. This is just a simple way that we can model, any polynomial. So why don't I just put some new values in here? I'll do -7. I'll do 3, 3, 26, 4, 2, 3, 9. And so obviously we're building a different polynomial here. And when I call this, I'm going to call this on, let's do -4 and see what we get. So we get 130,333. Yeah, that's pretty much it. This is just one way to use enumerate, and it's solving a kind of specific problem. Of course, enumerate applies to a lot of different things in different ways, as we'll see